Hello everyone and welcome back to my channel. So for this episode, I'm going to cover the last bit of using KiCAD to design your customized PCB. And I'm going to cover how to optimize the area of your PCB to make sure that there's no empty space on it to better use the area of your device and your product. And also, I'm going to give you some general tips of real manufacturing designs of a PCB. Comparing to previous episodes, I'm going to target your PCB designing for real manufacturing and fabrication so that, for example, there are some of the tips I've covered before, like increasing the gap between the tracks or including the width of the tracks. These might not be helpful for this setting. So without further ado, let's get started. I'm going to still continue to use the example of my previous build PCB here. And to show you the difference, I'm going to have like two boards here, and you can have a look of them all together. So on the left, this one is the PCB I printed in our lab, which is a one-side printing. So like on the other side, like there's nothing, no copper, no tracks, there's no pad at all. So like what I have been telling you from the previous episodes, I was mainly targeting the PCB printing in this case, like one-side printing without like double-side printing. But in real PCB fabrication and manufacturing, these are the PCB being printed, and in most cases, like they can do like double-side printing pretty easily. So, for example, you can see notice here that there are pads for my Arduino CL board here, and those pads, like this pad here, they are actually automatically connected to the pad on the other side. Like they are internally connected altogether. So this makes our PCB design more easy, makes our design easier because we don't need to worry about like whether the LEDs and the Arduino microcontrollers or the OLED screens shall be on the same side or the other one. So this is pretty useful for us. And also, like as you can notice, like there are masks on the tracks here, so you don't need to worry about like whether your solder will be attached to the tracks or other pads here, then causing a solder bridge, which will cause a shortcut of your device. So that's why that I'm recording this episode of my tutorial, because I think this will be helpful for your real fabrication of your PCB. So what I'm going to do first is to try flipping these LEDs here to the same side of the microcontroller or the stepper motor and etc. Because like imagine that when you are using your PCB device, you want the user to read the light status of the LED while they are manipulating it. For example, for my current setup is you turn my device on like this. Yeah, you can see that the step motor is working, which is initializing right now, and the OLED screen is working. But you might notice that the LED indicating the power status is on the back, and the user cannot read it at all on the front side. So this is a little bit annoying and also not user-friendly. So that's the thing we want to avoid here. So what I'm going to do the first is to flip these two LEDs to the other side of the board. So anyone, do you remember what's the shortcut of flipping? So I guess you know the answer already. It's F, right? So I'm gonna flip these buttons, not buttons, these LEDs to the other side of the board. And for the rest of the resistors here, I think they're okay to stay here because they are easy to be soldered here, and there's just like no need of them to be on the same side as those like real interactive components on your board. So what I'm gonna do is to cut off the existing wires here, the tracks here connecting to your LED, because like these red tracks, like they are actually on the front side of your board, but now you want them to be on the other side of the board, or the back of it, so they can connect your your tracks or existing circuit to the surface mount soldering device on the other side. So for doing this, what we need to do, or what we need to use, is a thing called VIA. So if you don't know what VIA is, you can just like say like type in VIA PCB, and here like that's the definition of PCB vias. It's actually like a hole on the PCB, and the both sides are actually connected, and it can kind of like flipping your track on one side of your board to the other side of it. So like for some simple one-side PCB printing, those vias are always treated as holes or drills of your board, and of course with some copper connected, but those two coppers on each side of the board, like they're not connected. But for real PCB fabrication, connecting them is easier. So like if you order it from a real PCB manufacturer, if you are using VIA, you don't need to connect those two sides of the VIA by yourself manually. They are already connected by the PCB manufacturer, which is pretty convenient for us. So what I'm gonna do here is to continue this track, and I'm gonna press, you can guess the short key for VIA, right? Because it starts with V, so V. And then I can put a VIA here. And you might notice that the color of this track has been changed to blue, because blue means like this track is on the other side, the back side of the board, which is what we want actually. And as we can notice that it wants this track to be connected to the ground, while the ground is actually on the left side of the LED. So I'm gonna rotate it, and then I'm gonna use this. Oops, this is not good, because like if you are using the front line or front track to connect it, as for now, it won't be attached or snipped onto this D1 LED pad, because that's not the desired track it wants. It wants the track on the other side or the back side. So use BCU, which means copper on the back, and connect them. Nice. And then, since this pad is on the front side of the board, I'm gonna use it. I'm gonna connect it like this. So perhaps, okay, and then nice. So by using those two vias here, we can connect this LED with the existing circuit pretty easily. And now I will do the same thing for this one. Let's see. A via like this, and a via here like this. And okay, it still wants a connection here, but I'm just gonna use the front side to connect them. I don't think this is a good connection, so I'm gonna use a via once more, perhaps here, and connect it with this pad. Looks nice. And then we can use the design rule checker here. I'm gonna bring it to this window, run it. There are some errors here saying that tracks are not connected, which is not good. Let's see where the problem is. Let's inspect again. Oh, no need. No, this is a warning. I'm not gonna showing up on all the warnings. And connected. This item is unconnected. The track net D1A on FCU is not connected to the PCU. Okay, it says that I think this is fine. Like this is fine. If we use Alt and F3 here, Alt and 3, sorry, not F3, we can see the simulation of our board here, and they are vias like this here, and we can notice that this track is connected to D1 here, and okay, this D1 on the other end of it is not connected. I see. So why is not? Why is it not? Let's check. Alt and 3. If you're wondering like how am I moving the board like this, I'm holding the scroll button on my mouse and then like moving it, and I can scroll my scroll button on my mouse to like zoom in and zoom out, and then using the left key to rotate the view. So I wonder, the problem here is that, yeah, this via is not connected to D1. Okay, so this via is not connected to D1. Oh, I see. There's something wrong. So let's connect it once more. Use V. Okay, let's check if this time we can pass the design rule checker. Run DRC. Boom. Okay, still unconnected items, which is weird. Where is it? Net D1 to A. I think they are connected, like they should be. So like if you really like wonder like whether these VS can connect those two tracks on either side of the board, you can just like add a copper wire to the board later to make sure like they are being connected through that wire internally. I think this is good for now. And what I'm going to do next is to optimize the layout of my board, because like you might notice that there's an empty area on my board here, which like kind of means nothing and like takes up the place of my real product, which is super annoying. So what I'm planning to do is to move all my devices here, as you can see, like all these kind of things a little bit upward. For example, if I can move my potentiometer a little bit to the right side, and here a little bit to the right side, and those two connectors, maybe let's put them a bit to the right side. And we might squeeze the space here, and by moving them all upward like this, right? And as you know, like these items here, like they can be hovering on the air, like all the things you need for the potentiometer here are the three pins here. So you don't need to worry about like these big items. It can be outside of the pad, of the board. So I think this is a better looking of our PCB. So what I'm going to do starting from now is to optimize my board like that. If you think this is like a bit useless and like not that meaningful for your PCB manufacturing, it's okay. Like you can skip this because I mean, like you don't need to make your PCB like super good, like extremely good. Like there's no need of doing this. But if you want to try your best to like create a best PCB that you can design, you might want to follow my steps here to make sure that your PCB will not create such an empty space on your board. You definitely want your space, especially the space of your real product, to be well optimized and not taken by those empty areas like this. So let's remove all the things, at least here. And also make sure that you are keeping the components here. Like don't remove them. Okay. I don't need to move that connector. Okay. So what I'm gonna do first is to make sure that these components are here, like they will be squeezed a little bit to the upper side of my device. Okay. See, we can definitely have a routing like this. Right. And R3, maybe we want it like this. Just do some like dangling wires here. Let's get rid of them. And LED, make sure they are near the resistor they meant to be connected. Okay. Don't move them too close to the resistor because we need vias here. Empty this. Okay. Okay. Looks good. Let's clean all the vias here. There's a dangling wire there. Okay, let's move it closer and move the connector closer. Also move the switch closer, and I want to make sure it looks like this. And let's move them upward. Okay. So what I am planning is to move them like this, and as you can see, like this D2 LED is blocking the way, so I'm gonna move it downward like this. If you are wondering how am I dragging the wheel like this, I am holding my right click on my mouse and then dragging the wheel like this. Let's select them and move them here. Okay. Not that okay. Maybe a little bit here, here, and here. this definitely looks better, right? Okay. I think it looks nice, and there's no like real like the empty space has been squeezed from like this bit to a little bit like this, right? And since we want a rectangular PCB for us, there's no chance for us to like cut this small piece of the board off. So I'm just gonna stick with it. Or I can just, let me try if I can. Yes, I can move all the resistors. No, not this one. This one is not. It won't go. I can. Okay, I can't. Okay, why not just stick it with like this? Okay, I think this is good enough. Or is there like any better way of me doing this? Okay, I guess so. So what I can do is to better utilize the space here. Like move this power connector here, and the resistor can go like here, and the switch then can then be moved to here. Had I got the chance of yes, I can set the button like this. Okay, nice. And therefore, I can just have a really clear cut like this here to make sure like the board area or the space that my board will take is like minimal. So I'm gonna clean the edge cuts here. Select edge cuts, then increase the grid and make sure I'm doing the right thing. Oops. Just draw a line. Why is it not? It's not following the grid. Why? Oh. Okay, I don't know why it's not following the grid. Maybe we can deal with it later. But as you can see, the angle here, like if the angle is correct, there's no need to worry about the grid. Like we want the theta to be exactly 0, right? That's the point. I see. Okay, looks nice. So like what I want to do next is to route all these components here again. Okay, so this would be a relatively boring thing for you to do, but like this is definitely kind of unavoidable, and we can just try it like this, right? Okay, let's go here. VCC, it goes here. Okay. Okay. I think these are all okay for us. Okay, so here's the problem. The I need to figure out like where to put the via here. So let's connect them first. Use V. Okay, nice. Okay, nice. So like we can make sure those surface soldering LEDs on the back are being routed first, because like the positions of these vias will determine like where can we route later. And hold the battery here. Okay, let's use the far away here. Ground, ground. Where's the real ground? There's no real ground. Okay, it's here. So maybe. Okay, that's acceptable. And you can be here. You can be here. You can be here. This sucks. I want the potentiometers controlling pad to be here, but I'm blocking the way. So let's see if there's another way of doing that, especially for this ground pin. And we can first make sure that we are not blocking this pad here. Okay. And for the ground, okay, nice. This won't be a troublesome because like if you are printing this board in our PCB lab with the laser cutter, this might be troublesome. Like there will definitely be like short between those tracks here. But like if you are sending this board to a real manufacturer, there won't be any problem as long as the gap between the tracks are set as are set in your net classes setting as this. Like, don't need to worry about that. The clearance, if it's setting like this, there won't be problem. And okay, so here's the trouble. Here's the trouble. Yeah, as we can see here, we cannot connect the button to its desired place because this battery routing is a little bit poor. So what we can do here first is to connect the button first. Maybe we need to like make sure that the button is connected to here, and battery actually can go from here. Yes. Okay, any unconnected items so far? I think not. Let's check. Designer checker. Done. Nice. Okay, there's only one disconnected item here. That's because like these button pads are internally connected, but I can still connect them like this here. It makes no difference. Okay, so this will give me a pretty like a really better PCB compared to my previous iteration, where all the devices are being squeezed together. There's no such an empty space on it. And all the LEDs here are on the same side as those like display components like the OLED screen, the step motor, potentiometer, all the buttons, switch, whatever, which is pretty good. I like it. I like this board definitely better than my previous iteration. And I hope this will be the same as yours when you are designing your new iteration of your PCB. So that's the tutorial I'm making today, and this will be the last episode of my KiCAD tutorial so far. For the future tutorials, I'm going to cover more on the microcontroller side, like how can you code on these Arduino ESP32s to make sure like you can connect devices or control the devices like step motors, OLED screens, and whatever machine learning models you are using on your board. Also, like I will teach you how to control them like in a asynchronous way of using the FreeRTOS it's kind of like an operating system on the microcontrollers to make sure that you can control those different devices with different threads asynchronously. Okay, so that's all for my today's video. Thanks for your watching. Bye bye.